post this sometime today, and then you can review anything that you need to review. Okay? Yeah. Yes. Yeah. Okay. Yes. What's that?
There's no calculators allowed?
No calculators at all. Sorry. It's the way it is. Okay? The problems are designed so you will not need a calculator on this test. Okay? In future tests, I will have a little calculator section, but not on this one. Okay? You don't need a calculator. No notes, no cell phones, no calculators. Okay? All right. You'll have the whole time to do this. So one of the first things that I want to kind of look at is in college algebra, there's a lot of just fundamental stuff that you can do in your head without a lot of calculation. So one of the first things we learned about is a piecewise function. Piecewise functions, be sure you study it because you'll have to graph and you'll be able to have to make some sort of an interpretation based on this thing then. Okay? So the first thing is I'm asking for what f of negative 3 is. Okay? And I do give usually a multiple choice part of this in college algebra. I do give some multiple choice questions because there's a lot of fundamental things that are pretty easy to look at. All right, now you have two choices. You're either going to plug the negative 3 into 6x or you're going to plug it into x minus 1. Well, what's the deal? Look at this right here. If x is less than negative 1, then you're supposed to plug into 6x. Okay, is negative 3 less than or equal to negative 1? Yes. So what you do is you're going to do 6 times negative 3 to get negative 18. Okay, so that's the answer to the problem. What this is testing over is, do you understand what that inequality means? Okay, you can add this to this if you wanted to as well. What if I said f of 10? Okay, is 10 less than negative 1? No. Is 10 greater than negative 1? Yes, so what do? You work with x minus 1, so you do 10 minus 1 would be 9 like that. So what you need to understand is a piecewise function. How do you evaluate a function? All it means is make the determination of which function you plug into. Does that make sense to everybody? Okay. Now the answer choices on these things sometimes, I know what mistakes students make, so don't fall for that. So be careful about that. Okay. All right. Now these next two problems go together. Okay, so let's just kind of talk a little bit about even functions, odd functions, and what they mean. Okay, first of all, an even function, there's a couple of things you want to study. How is an even function symmetrical on its graph? Silence, that's a bad thing. Okay, all right. Y-axis, very good. Okay, all right. How about a odd function? The origin, good, okay. Now, what you need to know about that is an example would be something kind of like this. Because you don't want to just memorize that, you want to understand it. Say, for instance, you had a point, say that this is a point 2, 1. Then the point over here would be what? Negative 2, 1. So the thing that we talked about is even functions, if you have an opposite x, you have the same y. That's the way I try to get students to understand even functions. It just means opposite x, same y, like that. Okay, origin works like this. If you had a point, say 2, 1, then that would move over here to negative 2, negative 1. So origin symmetry means opposite x, opposite y. Okay, that's what you got to do. Okay, all right. Is this thing on number 2 symmetric about the y-axis? No, so forget even. Is it symmetric about the origin? No, forget odd, so it's got to be neither. Okay, the idea is, like if you look at this point right here, it looks like this might be, I don't know, I'm just predicting. It looks like that might be a 0.43, for instance. Okay, there would have to be a point negative 43 in order for it to be symmetric about the y-axis, and then you'd have to have negative 4, negative 3 for it to be symmetric about the origin. Okay, like that. Okay, how about number 3? How is 3 symmetric? Origin. So what's the answer? Odd. Okay, so one thing that you want to be sure that you study is odd and even functions, what they mean, their symmetry, and so forth like that. Okay, so be sure that you go over and study over that kind of thing. Okay? All right, so what did we say even functions were symmetrical about? Y-axis. Odd. origin. There you go. Okay, that's it. That's the key thing. Okay, now we're going to look a little bit at some circles. Okay, the standard form of a circle, when we learned way back about circles, was x minus h squared plus y minus k squared is equal to r squared. Okay, so the center of the circle is hk, and the radius of the circle was equal to r. Okay, so that's what you need to remember, is that thing like that. Now this problem right here, you have x minus 8, and then you have plus y. Now notice you don't have y minus something, so you could put y minus 0 if you needed to, then that's equal to 49. Okay, so what's the center? Okay, it comes from these numbers, right? 8 and 0. Okay, so it's got to look like this. It's got to have two minus signs. So that means the center is going to be 8, 0. And then the radius is not 49 because that says that's the square of the radius. So what's the radius? 7. So see, that's really r squared equals 49. So if you take the square root of both sides, then you get the radius is 7. So you have that center and you have that radius. Okay, so it looks like the answer to that problem is choice C. Okay, like that. Now let me just kind of remind you of one thing real quick here at the side. What if you had x plus 2 squared plus y plus 3 squared equals 5? Because I can ask this in all kinds of different ways. What would the center be? Not 2, 3. Be careful. Negative 2, negative 3. Okay, the sign's got to go opposites like that, right? And then the radius would not be 5. What would it be? Square root of 5. Okay, so the thing is, you got to be kind of careful. That problem's a little bit harder than that one. The general form is to have minus signs there. So it's going to be, you could write this as x minus negative 2 squared plus y minus negative 3 squared, like that. That's why the answer is negative 2, negative 3 for the center. Okay, so be sure you study that and pay attention to that. Okay, and then the radius is always going to be the square root of whatever that number right there is. Okay, the 49. Okay, does that look good? Okay, so that's a standard way to test a student over that idea. Is you need to know the standard form of circle. Okay, real simple thing. I give you a graph, you tell me if it's a function or not. What is this, yes or no? No, how come? Got that vertical line test, okay? So if you can find a vertical line that goes through, that's not very vertical, but you get the idea, okay? It goes through 2 points, okay? So you got that, all right? Okay, so there's a lot of kind of straightforward things on this multiple choice part. Okay, I give you, on this one, I give you a relationship like this, okay? How do you find the domain? It's all the x values, okay? So basically the domain on this would just be all these x values, negative 2, negative 8. You have negative 2, you have negative 8. Now you have an 8 twice, so you don't have to write that twice. So that's the domain. It doesn't matter what order it's in. And what's the range? What do you look for? All the y values. So the y values are negative 3, 3, 7, and 1. Okay? So which one does that match up with? Is that A? Yeah, that looks good. Okay? Like that. All right? Now, let me ask a question on this, too, because a lot of times I like to ask this as well, is what if I ask you if that's a function or not? Okay? If you looked at the points on here, you would have a point negative 2 mapping to negative 3. Then you would have a point negative 8 mapping to positive 3. 8 would map to 7. But notice also that this 8 would map to 1. Is that a function? No. How do you know? Okay, you got an x that's going in 2 or more directions. Okay, so that would not be a function. Okay, like that. Okay, all right. How about the next one? Is it a function? Yes or no? Okay, no. The reason is because of this. Okay, the 1 basically is going to 2 places. It's going to 1 and it's going to 11. You can't have that. And also notice the 2 is going to 5 and the 2 is going to 9. Like that. Okay, functions basically every x, what does it go to? 1y. Every y value has exactly 1 x value. Okay, so that's what you got to study on that. Okay, all right, here's a question about I'm giving you a point. Okay, I'm giving you the point 1.5 and negative 1.75. We're going to find a point that's symmetric about the y-axis. Okay? So here's kind of the idea. I'm just going to roughly plot this point. This point is over to the right, and it's down some number of units. Okay? So if I move this over the y-axis, what changes in that point? The x value or the y value? Or both? The x value only, right? It's still going to be down the same amount, isn't it? But that x value has to move over to negative 1.5, negative 1.75. Okay, so that's how that's going to go. So which choice is that one going to be then? Yeah, C. Okay, like that. What if I did this? What if I said about the origin? Let me just kind of give you another example. Say like you had a point 3, 2. If I want that to go to the origin, where does it go? Negative 3, negative 2. Like that, okay? So that's the idea, is something changes. If you forget it, draw a graph, and then you'll figure it out, okay? Because a lot of times students try to learn this math too much by memorizing. If you draw a picture and you know what it means to be symmetric about y in the origin, you can easily figure it out, see? So that's the idea, okay? All right, any questions with that? Okay, so on the test, generally I try to give a certain series of multiple choice questions. You're welcome to guess. Doesn't make any difference, but hopefully these are kind of short answer things where that you don't have to really write any work on. Now here's a graph. So we've been talking a lot about transformations. Okay, so this is a quadratic, so it's x squared. Now let's look at what transferred on this. A basic parabola does this. Okay, how did that thing change? It moved to the left, and I can't see very good. I'm assuming 6 because there's a bunch of 6s in the answer choices. Left 6, what else happened? Good, it reflected over the x-axis. So that means that in the transformations that we learned, first of all, what you're going to do is if you make something go to the left 6, you've got to do plus 6 inside the parentheses, like that, okay, like we learned. Now, how do you make it reflect? You put a negative in front like that, okay? So that would mean the answer choice on that is going to be like that. So this is just kind of the different things that we learned about transformations, okay? One thing that's kind of a worthwhile thing to just kind of look at is, in general, I'm going to write down an example here, and I'm going to use absolute value. You can write this down if you want to. Let's say, for instance, that you had this. That's got almost every type of transformation we talked about, okay? So what does the minus 3 do? It's inside the absolute value, so what does it do? Takes you to the right 3, good. What does the minus 6 do? That's outside. Down 6, okay? Does flip. Okay, that reflects over the x-axis, okay? Now, if you think about it this way, if you think of this as multiplying y by 2, the y values get bigger. You have a V shape, so how would that affect the graph? It stretches it, exactly. So if you have a number in front like that, that's going to be what we call a vertical stretch, or it's going to be a vertical shrink. It depends on what the number is. Stretching just means the y's get bigger. Shrinking means the y's get smaller. How do you shrink it? You don't put a 2 there, you put a fraction there. That's between 0 and 1. So in general, that's what I'm really testing you over in all kinds of different ways is, do you know how all these transformations work? So you want to be sure you study that, okay? All right? Okay, questions so far? Good, bad? Feeling confident? Okay, don't get overconfident though. Okay. All right, inequality. I always like to have some sort of an inequality on the test somewhere. That's a pretty standard thing that we've learned how to do. This actually is something that a lot of you did maybe in an intermediate algebra class. All right, so let's solve this inequality, and I'm usually kind of checking for these kind of things. All right, so first thing is we want to get x isolated on probably the left side on an inequality. So we're going to start by carefully doing the distributive property. So that's going to be negative 6x minus 8 minus 10 less than, and then that's going to be 8 plus 4x minus 8 like that. Okay, then what? Like terms. Okay, don't start rearranging stuff. I always see students do that. Just put things together. That's negative 6x minus 18 less than, I see the 8's cross out, so that's kind of nice. Then you have 4x like this. Okay, now you can just start rearranging. You don't really have to show any steps on this. What you can do is just move the 4x to this side and move the 18 to this side. So if you do that, you're going to have negative 6. The sign changes on the 4x, so it's minus 4x. And then the sign changes on the 18, so then you end up getting that. Okay, like that. Okay, so now when you do this, you have negative 10x less than 18. So that's kind of like an equation. Usually students in college algebra have got enough experience they can do that part fine without a lot of mistakes. Now what I'm going to do is I'm going to divide by negative 10 on both sides. So what does that tell you to do? Got to change that sign, right? Anytime you multiply or divide by a negative, you got to change that sign, okay? Now, you can reduce that fraction. So if you got 18 over 10, you can divide the top and bottom by 2, and that would give negative 9 over 5, okay? Then we're going to do a graph and write that in interval notation, okay? So I'm always kind of looking for that. I try to test over as many things as I can. So flipping that sign is an important thing to make sure that you know how to do. All right, now, if we're going to do a graph on this, the key thing is it's a fraction, so it doesn't really matter that much. All I want to see from you on this is that's really about negative. It's really negative. If you take 5 into 9, that goes in one time with 4 left over. So all you really need to know is it's between negative 1 and 2. So if you just put on your graph, if you put 0, negative 1, negative 2, that's good enough. Now, since it's greater than, which way do you shade? To the right. Do you use a bracket or parenthesis? Parenthesis. Okay. When do you use a bracket? If there's an equal to. Okay. So just kind of estimate where it is, put a parenthesis, and then shade all the way to the right like that. That's what your graph looks like. Okay. Interval notation, remember, does exactly what the graph does. So it's where does it start? Where does it finish? So I always said if you're going infinitely to the right, the infinity is going to be on the right. And then you start at the negative 9/5 and with a parenthesis like that. Okay, so one of the things you want to be sure that you go over and study, graphing, interval notation, solving inequalities. Okay, you want to know every situation that we've talked about there. That's a pretty good standard example. Okay, does that look okay? Okay, all right. Okay. Now, a couple of more things on circles. Generally, I give some sort of a problem that has a little bit more to do with circles. Yes?
So the only time you flip the sign is when you divide by a negative?
Or multiply by a negative. Yeah, okay. Any other time, you keep it the same. Dividing by a negative and multiplying by the negative are really accomplishing the same thing. Okay? Okay, let's see if we can figure this one out. Okay, this is kind of a good problem that has several things that we've learned how to do. So these are the diameter of a circle. Now what I think is probably helpful on this is I always draw sideways when I try to do this. Okay, so let's draw just like a little picture on this. And let's plot out our points just so that we kind of see what's going on. So that's negative 2, negative 3. Then we have a point that's 4, negative 7. Okay, kind of like this. Okay, so what you have is you have a circle that's going around those points kind of like that then. So your job is going to be to find the equation of the circle. So whenever you find the equation of the circle on this one's basically got several steps on it. So one of the things we're going to look at is let's start by writing down the equation of a circle because that's going to tell you how to do this problem. So you have x minus h squared plus y minus k squared is going to be equal to r squared. So see what you have to do. Anytime that you want to find an equation of a circle, what are the two things you have to know? You've got to know the center, right? What else? The radius. Once you get those, then you're in business, okay? So what you're going to do on this is the center of the circle is going to be somewhere in there. Don't go by looks. We learned a formula that tells us how to find that. How do you find that point? You do the midpoint formula, right? okay? So that is going to be the center. So when we do the center, what you're going to need to do is we're going to need to do the midpoint formula. I don't give you the midpoint formula because it's not very hard to remember. When you find the midpoint, what you're doing is you're averaging two numbers. How do you average numbers? You add them up and divide by 2. So what you would do is you would take the x values and average them. So you just take -2 plus 4 and divide by 2. Then you do the y values, same thing, add them up, take -3 added to -7 and divide by 2, like that. Okay, average. Okay, so -2 plus 4 is 2, and then you got 2 over 2. This is -10 over 2, so that's going to give 1 -5. Okay, now I want you to look at my point. Does that look pretty sensible? That's the reason I ask you probably to graph this, because that way you can catch a mistake. It looks, 1 -5 looks pretty accurate, doesn't it? Okay, so that means that the 1 is going to go there, and the -5 is going to go there, okay, when you get your answer. So if I give you the endpoints of a diameter, the center of the circle is the midpoint. Okay, midpoint formula, just think of it as averaging two numbers, okay? Now, the next thing I want to kind of look at here a little bit is, let's kind of think about what the radius is, okay? So the radius is from the center to that point right there. You have to find that distance. So how do you find the distance if you know 2 points? You do the distance formula, which you also got to know, right? So let's kind of review how that distance formula goes, all right? And I'll write the distance formula just kind of up here on the side here. So the distance formula goes square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, like that. Okay, you need to know the midpoint formula, and you got to know that too. I don't give that to you. Okay, it's not that hard to remember. That really isn't. Okay, so what do we have? We have these 2 points. This point is -2, -3. And this point is the center. We got that to be 1 -5. So what we're going to do is we're going to apply the distance formula, then we're ready to get the final answer of the problem. Okay, so the distance is equal to square root, and what we do is we do this. I always kind of like to get students to kind of get the framework built like this when you're putting this together. Okay, so what you're going to do is you're going to subtract the x's. The x's are -2 and 1. Doesn't really matter what order you do those in because you're going to square it anyway. Okay, then you do the y values. It doesn't matter what order. So you're going to do -3 subtract -5. Now be aware of that minus minus because it's going to pop up some. Okay, so again, what are you doing? You're finding -2 minus 1, then squaring it, then -3 minus -5 and squaring that. Okay, all right, this is one of the first things we did this semester. Okay, so this is going to be, if you work this out, that's going to be -3 squared. Okay, this thing right here is really going to be -3 plus 5 squared, so that's going to be 2 squared, like that. Okay, so that's going to give 9 plus 4, so that's going to give the square root of 13. So that's what the radius is it's the square root of 13. Okay, does that look familiar? Yes? No? Okay, you have to know. This is a good problem because it tests a lot of things. So what's going to go in here is, that's supposed to be an r squared there, is the square root of 13 goes there. Now we're ready to write the answer to the problem, say. Okay, so when we go through and put this together now, what we're going to end up having here when you plug everything in is it's going to go like this. It's going to go x minus 1 squared, because you're plugging in that value of the center. Then this is going to go y minus -5 squared. Then you're going to square the radius, which is square root of 13, and then you clean it up and write the answer and put it in the answer blank. Okay, like this. Okay, so when we put this all together, we're going to have x minus 1 to the second, like that, plus y plus 5 to the second. And then what are you going to do with the square root of 13 squared? What's that give you? 13. There's your answer. Okay. I always give this problem on the test. It's a good thing to have students do because you have to know midpoint formula, distance formula, equation of circle. Okay? That's a good problem because it tests all of those features at the same time. Okay? All right, be sure you study that midpoint formula, the distance formula, like that. All right, you guys got any questions? Okay, that's one of the more advanced problems that we did this semester. It's got a lot of steps to it. Okay. Now, let's move on to the next page on here and review a couple of these things. Now, these again are things that no work to do, just kind of observation knowledge type of thing. So one of the other things I'm always looking for is, do you know what the local mins and local maximums of a graph are? And if I give you a graph, can you write the intervals of increasing, constant, and decreasing? Absolute guarantee. Some kind of a different graph, but same idea. Okay, so the minimums, how many local minimums does this graph have? It has 2. Okay, and all you want to do is just name the points on this. Okay, so the points on that are going to be, and help me out because I can't see very good, negative 2.5, negative 3.5, and the other one is 5, am I right?
Yeah.
My goodness. How about that, okay? All right, how many local maximums does it have?
2.
It has 2. So that's a local max. That's a local maximum, so that is, I think, negative 8.5. And then this one is what, 2.2, 3.9, yeah.
The graph keeps going on, wouldn't it be infinity?
But, okay, and I know exactly what you're thinking there. A local maximum, it doesn't matter. What a local maximum means is it's just a little neighborhood. It's just a high point in a little small neighborhood. What you're thinking about, and I know you've got a background for that, is if I ask for what's called an absolute maximum, there is not one in this one. But what a local minimum really is the function increases, hits a high point, and then starts decreasing, like that. So local just means a little neighborhood. Okay, good question. Okay, all right, any questions? Okay, students usually get that okay. All right, now let's look at the increasing, decreasing stuff like this, okay? So first of all, if you start here, all this is doing is the y values are getting smaller. So in that area there, the graph is going to be decreasing, okay? And then if you go from this point to this point, the y values get bigger, so it's increasing. If it's flat, what do we call that? We call that constant. And then it's going to start decreasing like that. So it's just kind of think of, you're going downhill, you're going uphill, you're level, and then downhill like this. Now the key thing on this is you name the intervals with x values. This is where I see students mess up a lot, because they don't do that right. Okay, so we got to name these with x values, and we got to be aware of those open bubbles and that kind of stuff like this. The other thing that's kind of important on this is you always use parentheses. Okay, anytime I'm asking you for a interval of increasing and decreasing, never, ever, ever use brackets. Okay, that's another thing that you want to study real carefully. Okay, so increasing, where does it go on the x values? Increasing is this piece right here. So from where to where? Negative 3 to 0, right? You're looking at x values. So you're going to say negative 3 to 0 with parentheses. It doesn't matter that those are solid dots. That's part of what I'm testing you on too, okay? Constant is the flat part of the graph. So where to where? X's, 0 to 2, right? Okay, so you're going to say 0 to 2 like that. Use parentheses, okay? Now decreasing, it looks like it's going to go from negative 5 to negative 3 to begin with. Okay, then the second place is going to be from 2 to 5. Okay, and if you got those two intervals, what do you put in the middle? You put the union like that. Okay, so those are a couple of things to be sure that you pay attention to is use x values and always use parentheses. Okay, other than that, students generally understand this thing pretty well. Yeah.
Would the open bubble mean anything?
It has no bearing on this problem whatsoever. Okay, the idea is we don't consider like an end point. it's kind of like neutral. Like we consider that not to be increasing or decreasing, like that. Okay, that's how you're going to put that together. Okay. All right. Let's see. Next thing I want to look at is on the next page here. Okay, we already did this, so let's move on from this one. You can go back and I can go back and do that a little bit later, but that's the midpoint formula and the distance formula. We did that in a previous problem. So that's another basic thing. I might give you 2 points. You find the midpoint, you find the distance. If you know the formulas, you're probably good. If you don't, you're going to die, right? So be sure you study those formulas, okay? All right, here's another absolute guarantee, okay, for this class. Difference quotient, okay? You've probably done a bunch of those on your homework. And generally what I'm looking for is something that's quadratic, okay? Why am I going over this so much is because of future classes mainly. That's the idea, okay? All right, so let's put this together and take a look at this. We've done a lot of this in class, and we've had you guys practice this a lot. Okay, so a lot of times students have trouble setting this thing up. So the way that I taught you to set this up is basically like this. Put two parentheses.
Parentheses or brackets?
Brackets, either one. Probably brackets are better, okay? Then probably all over H like that, okay? All right. So what goes in the second bracket? The original function, exactly. That f of x is whatever I gave you. Okay, so that's going to go there. That's going to give 2x squared minus x plus 1 like that. Okay? Now, the way I've been trying to teach this is what's the only difference between the first bracket and the second one? Exactly. Okay, so what we're going to do is we're going to go 2 something squared minus something. Now, see, I got to have a set of parentheses on that. That's something that students always mess up on, is that kind of an idea like this. And then what you just put in there is you put in the x plus h, like that. Okay? Now we're ready to crunch it out. The rest of this problem is primarily an exercise in algebra. So does the setup look good? Have you guys got that down? Okay, I've worked very hard on trying to help you to get that one down. Okay? All right. Now, let's go through the algebra details on this. Now, I'm going to go through basically and just bring down the 2. Now, this thing you would FOIL at the side. Now, I'm not going to take the time to do that, but I'm going to just say that that's what you would do, and then you would record the result inside there. So if you went through and FOILed that, you would get x squared plus 2xh plus h to the second like that. Okay, do that at the side of the paper when you do that. Now, what is this minus going to do to the x plus h? It's going to change the signs. Yeah, it's like distributing a -1 through there, so that's minus x minus h plus 1 like that. Now, same thing here. This minus is going to change all those signs, so you're going to have minus 2x squared plus x minus 1 like this. Okay, now you're going to have a bunch of stuff canceling on this problem. So what did I always say happens to the h in the denominator on these problems? It cancels. If it doesn't cancel, guess what? You're screwing up. Okay, so what you're going to do is just do a distributive property. So that's 2x squared here plus 4xh, and then plus 2h to the second like that, minus x minus h plus 1 minus 2x squared plus x minus 1 all over h, like that, okay? So you're going to now start going through and you're going to find a whole bunch of stuff is going to cancel, and if it is not working that way, you need to go back and check your signs. So that cancels. In fact, anything that has that does not have an h in it will cancel. So the 1's cancel, the x's cancel. Notice that what you have left has h's in it. So I'm just going to move this over here. So we have 4xh plus 2h to the second minus h all over h like that. Now you can write the answer. What I've tried to get you guys used to doing is what can you do with that h that's in the numerator? You can factor it, right? You can factor it out. Okay, that's the best approach to doing this. So if you take that h out, you're going to have 4x plus 2h minus 1 all over h like that. Okay, so again, I'm just taking out that common factor of h like that. Now you cross it out, and then that's the answer of the problem. Okay, so the answer to this is going to be 4x plus 2h minus 1. Okay, guaranteed problem. Okay, quadratic. I like to test over quadratic because that's kind of the standard thing. In homework, you guys did different types of functions, so the quadratic is about a good level for a test. Okay, all right, any questions? Okay, study it and practice it. Be sure to do that. Okay, moving on. This is pretty fresh in your head. So I put one problem on the test that has to do with either inverse or direct variation. Not both, but just one of the two. So the thing that you want to study is if it's direct variation, what is the general equation?
Y equals K times X.
K times X. You have to know that. Okay, I don't give it to you. Okay. If it's inverse variation, and we did one of those today in class, what's the equation?
Y equals K over X.
Y equals K over X. Okay, if you don't know that, you aren't going to do anything on the problem. If you know it, you've got a pretty good chance of getting this figured out. Okay, so basically when we put this together, it's going to say Y, so you write that down, varies inversely as X. So that's going to be the inverse variation equation like that, like we did today. Okay, so notice what I'm doing is I'm giving you a Y, I'm giving you an X, and I'm giving you fractions. I may or may not do that. It just depends. I think you ought to be able to handle it regardless, though. Okay, so that's going to be 10/3 goes in for Y. Then we have the K, and then X is 1/3 like this. Okay, now you've got to take that equation and you've got to solve that for K. All right, now, the thing on this is, go ahead. Oh, that's a half, isn't it? I'm putting the wrong thing in. I did that earlier in class, okay? So let me correct myself on that and get that thing out of there, okay? That's the other thing I like about this. I can erase, which is great. Okay, so this is 1/2 goes like that, okay? Now, if I want to get K by itself, what can I do to both sides? Multiply by 1/2, because that's what I want to get rid of, right? A lot of times students freak out when they see all these fractions. Okay, the idea is if you just multiplied this by 1/2, that would cross all that out, wouldn't it? And then you just multiply this side by 1/2, and then your K is going to be by itself. Okay, like that. So what you're going to end up having is you're going to have K. You can cross cancel this if you want to. So 10/2 is really 5/1. So that's going to give you 5/3, like that. Okay, right? Now what we do is we go back to this equation like this. So that's going to be Y equals K over X. But now just put in for K, put in the 5/3 like that. Okay, everything look okay so far? Okay. Now, the next thing you got to do is find Y when X is 1/3. So what we're going to do is just plug that in. So we got 5/3 over, and then the X gets replaced with 1/3. Then you got to work out that fraction, okay? All right, when you're working this out, isn't that just really a division problem? Okay, yeah, you're doing 5/3 divided by 1/3. That's what it is. So how do you divide fractions? You flip the second one, and then you multiply. So that would be 5/3 times 3/1. 3's cross out. Answer's 5. That's a wonderful exercise in fractions, okay? So I always like to do something on these tests with fractions because the only way you're going to get better at it is just to deal with it, okay? And I still see problems with this in higher math all the time. Okay, so be sure from that you study those two equations, okay? There's nothing, the homework had something on there about a few things more complicated. I'm just looking at straightforward direct inverse variation. Very straightforward, okay? And I may or may not put fractions on it, I'll decide. What do you guys want? Want fractions or don't want fractions? Oh, good, you want fractions.
No fractions.
Okay, all right. Let's go through a couple of things with composition of functions. So composition of functions is another guarantee that you So it's a major area that you want to know how to do. Okay, most of this is just going to be some arithmetic. You're not allowed to use calculators, so I'm not going to throw anything real bad at you. I'm really not. Okay, so this problem right here, we're finding G composed of F of 26. Okay, now the way that I taught you guys how to do this is I think it's good to learn to write the first step like this. And then you have to go do this in a certain order. Okay, so we're going to find G of F of 26. So you want to start by doing F of 26. Well, how do you find F of 26 on this problem? You go to the function F and you plug in a 26. Okay, so you want to just kind of do that at the side of your paper. So you're going to have 26 minus 2 over 4. So that's going to be, what is that, 24 over 4. So that's going to be equal to 6. Okay. Now what you're going to do is go back to this part of the problem. We just found that F of 26 is 6. So we just plug that in like that. So I'm working arithmetic out, but I'm doing it in a certain order. So now what do I do with the 6? I plug it into the function called G. So I'm going to work out 7 times 6 plus 2. So that's 42 plus 2. So that's going to be 44, like that. Okay? So it's an arithmetic problem. And you've got to make sure that you know the correct order. The most common mistake students make is they do it in the wrong order. Okay? All right, let's see what we got kind of going on this problem. So what we're going to do is give you two functions, and we want to find G composed of F. Now, I don't give you a number like 26, so this just means you're going to compose the function, but you're not going to evaluate it. Okay? So which function plugs into which function? Which function do you plug in? The second one goes into G. That's the whole thing, is you want to make sure you do this in the right order. So what I tell students to do on a problem like this, if you're going to plug F into G, it makes sense to start by writing down G. G is something minus 3. All right? Now what goes in the parentheses? Exactly. Okay, so this thing right here is going to go into the parentheses. So you've got that like that. Now what you're going to do is you're going to work out anything. If you can work anything out, you just go ahead and work it out. You can't put the 4 and 3 together. I've seen students do that before. How come you can't put the 4 and 3 together? Well, that's in a radical. That's not in a radical. So the answer is really just going to be x plus 4 minus 3. That's your composition of functions. So there's not much working out after you plug it in. Sometimes there's things to work out. Sometimes there isn't. Okay? Now, this is a problem area right here for a lot of students. If I ask you for the domain of that composition, there's two things that you have to do. Okay? It won't really make much difference on this particular problem, but you always want to start by looking at the second function, and what you want to do is you want to find the domain of that second function. Okay? So that second function, what I'm talking about is G composed of F would be this thing right here. Okay, so we got to figure out what the domain of this is. So what kind of number has to be under a square root? Positive, or what else? Or 0, okay? So what you got to do is you got to take the thing that's under the radical and you set it greater than or equal to 0. That's how you find the domain, okay? So then you could subtract 4 from both sides, so you'd end up getting x has to be greater than or equal to negative 4, like that. So that's what the domain is on that. Now the second thing that you look at is you find the domain of the composition, okay? And it's going to turn out on this problem it's going to be the same. So for instance, so our composition is x plus 4 minus 3. Well, isn't that the same thing? Now you got x plus 4 under a radical, so x has to be negative 4 or bigger, okay? It has to be, and think about this when you get an answer. If x is negative 4, what do you get under the radical anyway? You get 0, which is cool, right? Okay, so that's the idea. So what we'd have for the domain, and you could just write it like this. You could say set of x is greater than or equal to negative 4. You can write it in interval notation if you want to. I don't really care which way you do that. So if you did interval notation, it's going to be written like that then, okay? So that's the idea, okay? That domain is always a little bit of a problem area. Let's do these next two problems, and then I'll pause here. Just on domain on this now. So again, with this number 19, the problem is the radical. What kind of number needs to be under a radical? 0 or positive. However, is it okay on this problem to have 0 in the denominator? No. You got to be careful on this problem. So it's slightly different than the last one. You got to set it greater than 0. It can't be 0 because it's in a denominator. Does that make sense? Okay, got to pay attention. Okay. Now we're going to add 3 to both sides. So that's going to be 2x is greater than 3. Then you can divide by 2. So you get x is greater than 3 halves. Okay, so again, you can write this like this. You can just write this as set of x such that x is greater than 3 halves. Or you could write that in interval notation and just write 3 halves to infinity like that. Okay? All right, it all depends on where the square root is. If it's in a denominator, then it can't be 0. Okay? All right, the next problem, what we want to do on this is you want to figure out what makes the denominator 0. Okay, and this one's kind of hard to do in your head, so I would recommend that you just write it down and do that. Okay, how do you solve that equation? Factor, right? So you're going to factor. So when you do this, this should tell you where this thing's equal to 0. You don't pay any attention to the numerator. The numerator doesn't matter. Okay, so you're just going to say x and x. What are the two numbers going to be that multiply to give 4 that add up to 3? 4 and 1, right? Not 2 and 2. So you got 4 and 1 with a negative there and a plus there. Okay, now what you do is you have x minus 4 equals 0. Then you have x plus 1 equals 0. So that means x is equal to 4, x is equal to negative 1. Those are the two problem areas. So when you write this domain, you're going to write it like this. The easiest way to write this is just say set of x, and then say x cannot be 4, and say x cannot be negative 1. Okay, because you're telling me what x can't be. X can be anything but those two numbers, so you write it that way. Okay. You could also write it in interval notation, and that would be like negative infinity until you get to negative 1, and then between negative 1 and 4, and then 4 and forever. Okay? And see, since we're using parentheses around those numbers, that's why that we're excluding those numbers from the domain, like that. Okay? All right, these are all big things to study. Now, like I said,